Hello everyone. Welcome to this tutorial video on exploring the steady-state analysis feature of Simba. This feature can help you to choose the final time to run the simulation, stop automatically the simulation when steady state is reached, save your time because you don't need to run several times the circuit if you don't know exactly when the simulation should be stopped. Let's show this from an existing schematic of a DC-DC flyback converter. Here, we are going to set up the transient analysis settings from the wheel icon. If you click on this icon, you'll see. First, let's check the solver type, including fixed time step or predictive time step. You will be able to find more information on the time step definition on our Simba website by going on documentation section and then simulation engine. Next, you will find the minimum time step by second. This is the minimum time step which will be chosen by the Simba solver in order to run the simulation. Of course, the time step would change and be increased in order to have fast and accurate results. Additionally, you have the option to select the Stop at Steady State function by ticking the corresponding box. Then you have the End Time section. This values needs to be set up in advance. Finally, let's try to run the circuit with end time equal 2 millisecond. As you can see into the progress bar, it takes few time to run the circuit and if it is really fast. Now you can move into Result tab and you'll see the R2 voltage signal of the load, and you can observe that there is an overshoot during transient analysis and then steady state is reached and end of simulation is 2 milliseconds. Of course, you can clearly see that steady state is reached before 2 milliseconds and time could be saved during simulation. The steady-state value has well reached the 4 volts as calculated in mathematical equation of flyback topology. Now, let's run again the simulation, but now we will check the box, Stop at Steady State, and see how much time the simulation will take. When clicking on the box, the end time is disappearing. Let's click on the icon, Run Simulation, and after few milliseconds we can observe when the steady state is reached earlier. The simulation is almost instantaneous. Finally, you can observe that final time into Result tab is around 0.7 milliseconds. So the steady state for this simulation is reached at 0.7 milliseconds, which is before the 2 milliseconds simulated in previous simulation. Thanks to this functionality, you can save time for any circuits. To sum up, when Stop at Steady State is enabled, the end time parameter is not used, and the simulation stops when Simba detects the steady state. This feature is particularly useful during a parametric analysis because each run can have different time constants, and the Stop at Steady State feature ensures that each run will stop at its steady state. To determine if the steady state is reached, Simba analyzes the RMS value and the highest non-DC harmonics, if any, of all simulated state variables. This explanation concludes this tutorial video about steady-state analysis. Thanks for watching.